So let's solve the next exercise. So show for every x in the interval 0, 1 that this inequality happens. So we can see here, so we have e to the x, and we have this sum, and we have in the other side also something depending on x. So it looks like that this sum is the nth the Taylor polynomial of e of x in around the point 0. So let's see. So letter A. So p n of x. Just remembering that if f of x equal e to x, then f of 0 equal 1. And that also the derivatives of these functions is the function itself. So it will be 1 plus x plus x squared divided by 2 until x to n. Just remembering that the Taylor formula is like this, okay? So it will be f0 plus actually it could be any point, right? So here we have x0, x0, x0 until the nth derivative, so 2 times push, no, until okay. So we see that definitely this is our Taylor polynomial, and this is our f of x. So we need to remember the Taylor's theorem. Taylor's theorem says that there is x bar on the interval x0 or x0x, depending if you're looking to the right or to the left. So there is some x bar around the x0 such that this happens. Okay, here to be x to n plus 1. So this here, it's called the Lagrange remainder, as we see. So this is and it is less or equal some m such that so here is the n plus 1 derivative. So here, what's the relevance of this result is that we have that this quantity here will be an upper bound for the error. On our approximation. Okay, so let's use that to solve the exercise. Okay, so we know that f of x minus p n x okay, for x in the interval 0, 1. So let's calculate f n plus 1 in any point x. It will be e2x. And for x, in this interval 0, 1, we have that the function e2x is increasing on this interval. So we can take our m equal e1, okay? So it is the maximum that this function will achieve on this interval. So we know that we can write that f of x minus x is smaller than e divided by n plus 1 factorial, and we know that our x0 equals 0, and since we are in the interval 0, 1, this will be equal x, so here times x to n plus 1, and we know that this e to 1 is approximately 2.781, so on. So, and we can write that this is this quantity here down will be smaller than 3 divided by n plus 1 factorial times x to n plus 1. So this is the letter A, and you can just substitute here the things that we calculated on the slide before. Okay.